This is the second video on the production possibility frontier, also called production possibility curve. Now, the previous video introduced the concept, and you remember we considered an example of a farm that has 9 fields, which you can see here, and each of these fields we gave a label, so field A, field B, field C, and so on, and we were looking at what happened when the farmer was deciding whether to use each field for grazing cows or for growing wheat. So before we kind of get started on the next aspect of this, let's just consider a little bit what we found the last time. So if we just kind of look at the bottom left of the screen here, what we did was we basically said, well, let's assume that the farmer, if he's allocating all 9 fields to wheat, then he'll produce 0 cows, because obviously none of the fields are for grazing cows. He'll produce 9 fields worth of wheat, 9 units of wheat, and that will be his overall output. Now, we said that he could then switch one of the fields, say field A, from wheat to cows, in which case he will gain 1 grazed cow, and he will lose 1 unit of wheat. The lost unit, remember, we called the opportunity cost, and that this was a choice that he made, moving along the PPF like this. And he could then choose to switch another field, say switch field B from wheat to cows. So again, he would gain another cow, he would lose another unit of wheat, and so on. And this would continue all the way along as he moved each field until finally we got to a situation where all 9 fields were being used for grazing cows, and then obviously no wheat would be produced. And that was kind of quite a simple way of looking at things. We did, though, make one very, very significant assumption there, and it's an assumption that really, as economists, we need to challenge. We assumed that basically each field was equally good at grazing cows and of growing wheat. So essentially, when the decision was being made to switch the fields, it didn't matter which field the farmer chose, because they were all equally good. Each field generated 1 grazed cow or 1 unit of wheat. And it was the same for each field, and the result of that was that we ended up with a PPF that looks like that. Now, what we need to do, though, in reality is consider a more realistic scenario. A more realistic scenario is going to be one where actually each field is not equally good at each of those things. For instance, the field may be on a slope, in which case it's much harder to grow wheat on it, and so on. So we have to consider the fact that each of his 9 fields may actually be not equally good at producing both things, and we need to think about what that does to the production possibility frontier. So let's consider this little table that I've added now. Down the left-hand column here, you can see that we've got our fields A through I. What I've done now, though, is I've challenged the assumption that each of the fields are equally good at both things. So you'll notice that field A, I've said, is very, very productive at growing wheat. So field A can generate 9 units of wheat by itself, but you could only graze 1 cow on field A. So it's very good at producing wheat, not very good at grazing cows. Field B is better at grazing cows. Field B could sustain 2 cows, not quite so productive at wheat, so we would only get 8 units of wheat from field B, and so on and so on, all the way down to field I, where I would be great for grazing cows. You'd be able to get 9 cows grazed on field I, but it would be hopeless at growing wheat, so you would only get 1 unit of wheat from field I. Let's think about what this does then when we think about our PPF. So the first thing we can think about, really, we need to get our end point. So we need to figure out what is the maximum potential production of each of these. So if we think about wheat, first of all, if we add up all of these numbers, we will get 45. Same for cows, just because of the way I've set it up here. So if the farmer allocates all of his fields to grazing cows, he can graze 45 cows. If he allocates all of his fields to growing wheat, he can generate 45 units of wheat. Now, those are important because they give us the endpoints of our lines. So we know that the maximum output of each of these is 45, and obviously if we generate 45 of one, we are going to generate 0 of the other. That's just the way it is, because we know that if he's allocating all of his fields to grazing cows, he won't be generating any wheat. So let's think about the situation. We will assume that we're starting over here. So we will assume that currently all of our fields, so all of these fields A through I, are being used to grow wheat. Now, if you were the farmer and you were deciding that you were going to use one of your fields for grazing cows, let's think about which field would you choose? Which would be the first field that you would reallocate in terms of its production, in terms of its use, from the production of wheat to the production of cows? Now, if you're being rational, the field that you would choose is field I. Let's think about why that might be. Well, if I switch field I from wheat to cows, I'm going to give up 1 unit of wheat, but I'm going to gain 9 cows. So the opportunity cost, which is the 1 unit of wheat that I give up, that's the smallest of any of the opportunity costs of any of the other fields. So that's the one that it makes most sense to give up. So what would that mean in terms of plotting it on my diagram? Well, it means I'm only going to give up 1 unit of wheat. So I'm still going to be kind of way up here. I'm going to be at 44 units of wheat. But in terms of my my cow production, I'm going to leap up quite substantially, not quite a quarter, so we're probably looking at somewhere around here. I'm going to get 9 cows. So what that means is the first point that I'm going to plot is going to be approximately here. So I'm going to give up 1 unit of wheat, that's my opportunity cost, but I'm going to gain 9 cows. So that is my first point of my new PPF. Let's think about the second one then. So same decision again. So at the moment I have A to H are growing wheat and I is for cows. So what am I going to do now if I decide I want to graze more cows? Which is the next field that I'm going to switch? Well, the next field that I'm going to switch, if I'm being rational, is going to be field H, because this is the next lowest opportunity cost. So by switching field H, I lose only 2 units of wheat, I gain 8 cows. So the advantage is not quite as big as it was before, but still quite significant. So what this means is that my output of wheat will drop to 42. My output of cows will grow by 8, so that will put me on 17. And that will mean that my next point that I'm going to plot will be somewhere around here. And again, what's my opportunity cost this time? Well, my opportunity cost this time is 2, from 44 down to 42. So from 44 to 42, that means the opportunity cost is 2. What do I gain? I gain 8 cows. So that means I have now switched fields I and H from wheat to cows. Which is the next field that I would do? Well, again, we can carry this all the way through, but the next field I would then take is field G. I would move field G because that's the next lowest opportunity cost. So at this point, I would give up 3, taking me to about here, I think, and I would gain 7. So I would be kind of moving up towards kind of this sort of area. So my next point is going to be here. And what you can see here is that this is generating a very different shaped PPF curve. And you can see that as I move along and as I move each field, the jumps on this wheat axis are becoming larger and larger. The first jump was 1. The first step was just 1. The first opportunity cost was 1. Next opportunity cost was 2. This one was 3. If I did the next field, that would be 4. So each time the jump on the wheat axis is getting larger. The jump on the cow axis, though, is getting smaller and smaller. What that will mean is if I plotted all of these other points, that actually they would generate a PPF which wasn't straight like the previous one, but actually, so let me hit these points here. Very good. Actually curves like that. And this is a more realistic production possibility frontier. It's more realistic because it takes account of the fact that, as we can see in the table here, the fields are specialised, and that we would start by switching the most the field that generates the smallest opportunity cost, i.e. we would start with this field, and we would gradually move the other fields. The very last field that we would use would be field A. Why would that be the very last field that we would use? Well, because if we were to switch it from wheat to cows, we would gain only 1 cow by doing that, but we would have to give up 9 units of wheat to do so. So what that would mean is that we would leave that field to the very, very end, again, assuming we were being rational. So what this demonstrates is a concept that we will return to much later on in economics, which is called diminishing marginal returns. And diminishing marginal returns occurs because the fields are specialized. So as we move them, the gain that we get, the return, of switching one additional field, which is what we refer to as being the marginal, gets smaller, as in it diminishes. So the gain that we got from switching the first field was 9, from the second field was 8, from the third field was 7, and so on. So the return of the next field was going down, diminishing marginal returns. That generates this curved PPF, and we consider that a much more realistic reflection of the production combinations of capabilities of an economy or of a business or something like that.